Alright, let's look at the question 8. Here, it asks us to calculate the duration of a bond. To calculate the duration of the bond, you need to know the equation for the duration. So for duration, if you look at our PowerPoint, the equation going to be t equal 1 to summation of t equal 1 to t times weight. So what is the weight? Equation of weight is each cash flow discount it to time 0 over the bond price. Which is like PV, present value of each payment, and the summation of each payment. That's your bond price. Okay. In this question, it gives us following information: the coupon rate, equals 6%, annual coupon payment, so it pay annually. So each payment would be 6% times $1,000. Bond par value normally $1,000, which give us $6 for the payment. Okay. It also tells us the period of this bond is 3 years, and the yield to maturity that equals 6%. Given those information, it would be easier for us to construct a table from time 1 to 3. So for 3-year bonds, we already know the payments for each year would be $6. But when it at T3, the end of the maturity, it not only pay you the annual payment, it also pay you the principal, which is $1,000 plus $60, that is $1,060. Then you want to get the PV of each payment. To get PV of each payment, you use $60. That's a cash flow over 1 plus y, which is 6%. That give us $56.60. Second cash flow 60 over 1 plus 6% to the power of 2. That give us 53.4. Third year, it would be 1060 over 1 plus 6% to the power of 3. That give us 890. If you add them together, it give you $1,000. Why is $1,000? Because this bond has 6% coupon rate, and the yield to maturity is also 6%. When these two equal, the present value of this bond should equal to its principal. When the yield to maturity become higher, like part B, goes up to 10%, it's larger than its coupon rate. The present value of this bond should be less than that, because it actually pay you less each year. If you hold this money, you should get a interest of 10%, but this bond only give you 6%. So that will make the bond cheaper, the present value of the bond cheaper. Okay. Now, let's calculate the weight. Weight is simply use the equation above. That's a present value of each payment over summation of each payment. Here we add them together, it gives us $1,000. So it's like for the first one it's 56.60 over $1,000. That gives us 0566. Next one gives us 0.0534. Next gives us 0.89. Next because you want to get the summation of t times weight, so you calculate t time weight. You use 0.0566 times 1.0534 times 2.89 times 3. If you add them together, you will get the direction for this bond, which is 2.8334. Okay, as I mentioned, next part B, other things stay the same because your coupon rate didn't change. The only thing changed is the yield to maturity. So your payments won't change because coupon rate not change. It's still the same payment. But when you discount the payment to time 0 to get the present value of each payment, the yield changes to 10%. That gives us 54.55. Next one gives us 49.59. Next one gives us 796.39. If you add them together, now the present value of this bond, or you can say the price of this bond, is 953. So that's different. When you calculate the weight, it's no longer the PV of payments over 1,000. It's actually the PV of each payment over the bond price. That is 900.53. Right? It gives us 0.0606. Next one, you do the same thing. 49.59 over 900.53. That gives us 0.0551. Next one give us 0.8844. If you notice, the weights should add up to 1 if you add them together. It should equal 1. Right? Then next column, you use weight times t. The third one should be 2.6531. If you add them together, that's your result, 8.238. It's slightly different, but that's the direction you want to get. That's all for question 8.